This section deals with a new law called Gay-Lussac's law that is related to the combined gas law as well. This one is a little bit harder to show visually or in cartoon form, but I'll do my best, and basically we can go without the visuals under some circumstances too. So the idea behind Gay-Lussac's law is that I have a gas in a container. The gas in my container, let's pretend it's a balloon, this gas has a certain amount of pressure on it. This gas also has a certain amount of temperature associated with it. What Gay-Lussac's law says is that if I increase the temperature, then the pressure will also increase by the same amount, assuming that I don't change the volume or the amount of gas that's in the container. So in other words, if I'm able to keep the volume the same, but I increase the temperature, then the pressure of the gas inside of my container is going to increase. What Gay-Lussac's law also says is that if I decrease the temperature, then the pressure is going to decrease by the same amount. Again, assuming that I don't change the volume of the gas in the container and I don't change the amount of gas that's in the container. So imagine that I have my balloon, I decrease the temperature, but I'm somehow able to keep the volume the same. If I'm able to decrease the temperature and keep everything else the same, the pressure is going to decrease. And so we can skip the mathematical treatment, but basically what Gay-Lussac's law says is if I change the temperature in the balloon, I can figure out the new pressure. If I change the pressure of the balloon, I can figure out the new temperature. And the formula for Gay-Lussac's law is a piece of the combined gas law. The formula for Gay-Lussac's law is the initial pressure divided by the initial temperature is equal to the new pressure divided by the new temperature. And if you look at the combined gas law, you can see those pieces here. P1 over T1 is shown in the combined gas law, and it's shown over here as well. P2 over T2 is shown in the combined gas law, and it's shown on the right side of Gay-Lussac's law as well. So this law is just a piece of the combined gas law again. And basically what it's saying is what happens to the temperature if the pressure changes and nothing else changes, or what happens to the pressure if the temperature changes and nothing else changes. And so we should do a problem related to Gay-Lussac's law as well. This is shown here. What's the new temperature in a tank of helium gas if the helium gas has a pressure of 250 torr at 0 degrees Celsius, and then you heat the tank of gas, the tank of helium, to give a new pressure of 1500 torr. What's the new temperature if we start out at 0 degrees Celsius, an initial pressure of 250 torr, and we increase the pressure on our tank to 1500 torr? And the assumption is that assume that the volume and the amount of helium in the tank doesn't change. So we need the formula for Gay-Lussac's law. It's this: P1 divided by T1 is equal to P2 divided by T2. And basically we just plug in the relevant pieces of information into the formula. If we do that, we get 250 torr on top. We have to convert 0 degrees Celsius to Kelvin. That turns out to be 273 Kelvin, is equal to the new pressure, 1500 torr, times X Kelvin. And so if we want to figure out the new temperature, it's X Kelvin here. We cross multiply and divide. If cross multiplying, we get 250 torr times X Kelvin. That's shown here, is equal to 1500 torr times 273 Kelvin. And to get X Kelvin all by itself, we divide both sides by 250 torr. When we do that, X Kelvin is equal to 1500 torr times 273 Kelvin divided by 250 torr. And again, you can see that we have torr in the numerator, torr in the denominator. Those cancel. The only units we're left with are Kelvin. So X Kelvin is equal to 1500 times 273 divided by 250, which is about 1638 Kelvin. Or if you wanted to write it in Celsius, you would subtract 273 and you would come out with 1365 degrees Celsius. So again, Gay-Lussac's law is just basically saying what happens to the temperature if we alter the pressure, or what happens to the pressure if we alter the temperature. In this case, we increased the pressure. We went from 250 to 1500, and because of that, the temperature also increased. We went from 0 degrees Celsius to 1365 Celsius. And that's it for Gay-Lussac's law. There is one other law to go over, and then one other concept beyond that law after this section. The next law is called Avogadro's law, and we will get to it in a moment.